Hello and welcome to our webinar about the WebAppBuilder extension for RapidMiner. We, that is Auto Computing, developed an extension that allows building web apps comfortably and fast, all within RapidMiner. In this webinar, we want to first tell you briefly about us and why we think that web apps can be very important, not only as a final product at the end of a project, but also as a stepping stone that guides the project. We want to show you one example of such a project where web app plays a big role. We want to build that web app and want to show you the principles and core features why we do so. At the end of the webinar, we will also show you some other examples of web apps that we've built and that you could also build with little to no training, especially if you are already familiar with RapidMiner. Before we delve into the details, let me tell you a bit about us. I'm joined by my colleague Hartem, who played a substantial role in the development of the WebAppBuilder extension. My name is Chris, I'm a data science consultant, and I've built several web apps already using our extension. So the majority of this webinar will be from a user's perspective. Why do we think that web apps can be very important? In our view, we offer data science consulting, and we've learned a few things over the years. One of them being that good machine learning results do not guarantee successful projects. We've had several projects with, in our view, amazing results fail because they weren't accepted. And we've also had projects with, in our view, not so good results succeed. And overall, the adoption of data science is more of a social and organizational thing rather than a technical one, oftentimes at least. So it's more about whether the methods are understood and accepted in the company rather than just some high accuracy number that is sufficient. As a company, we specialize in helping companies establish data science from the very start. And for that, we made a standard process, which is called SPATS, the standard process for the establishment of data science. If interested, we can tell you a bit more about it. But for now, we just want to show the web app part of it. Because several problems that we encountered are, for example, the cost of deployments, especially when you've had just some kind of proof of concept in a kind of small, with a kind of small cost. And after that, the customer thinks that it looks quite good and they want to actually deploy it. There's a lot of overhead going into the deployments oftentimes, and that's one of the problems. Another one is that the expectations between the data scientists and the customers can often differ. And just as a side note, as I said, we do data science consulting. And so we typically speak of a customer as the person who wants, in this case, a web app being built or a project being done. If you are doing data science within the company, that terminology might be slightly confusing, but we're just going to keep using it. And also, we speak about data science all the time, of course, mainly because it's with RapidMiner, but the web apps are obviously not limited to that. So another problem is that usually at the start of a project, not everyone really knows what they're going into, what they're getting into. We've often had the experience that in the company, the decision is made that they want to do something with data, something with big data, and they don't really know what they're getting into. And especially the end users aren't really involved and don't really understand what the data science project even encompasses. And that typically doesn't change within the project. So even at the end of the project, we often had cases where not everyone really knows what's going on. And all of that really results in a lack of acceptance, both from end users who weren't involved from the beginning, and also from the management who doesn't really understand what's going on. So one solution for that are prototypical web apps, especially if they're easy to build, because they allow the customers and the end users to see the implications of the project very early on. They have something tangible that shows what the project can do. It also understands what what the project means to them, because they can see in which way they can use the results, and they can also follow the progress, because these web apps, as we will see in a few minutes, are easy to build in a way that they are linked to the RapidMiner repository. So whenever you make progress in the project and have better models, that reflects in the web app. And all of that helps the customers and users to be really involved in the project. And also for the data scientists, it's helpful to understand the requirements of the customer better, because you have something tangible, and also work towards more concrete goals. So what's required for that? It has to be quite fast and easy, because web apps aren't a new thing. You can obviously build web apps already, but the thing that we want to show is that they're simple and easy to build for a data scientist alone. And our requirement is that it's possible to do it in RapidMiner. Because, for example, I am very comfortable within RapidMiner, but not so much with other programming tools. So when can web apps help? We have everyone's favorite, the CRISP DM. For those who don't know it, it's the cross-industry standard process for data mining, which are a lot of words, but it's pretty much just the steps that you typically follow in such a project. And the first steps are understanding the business and understanding the data. And after that, you go on and prepare the data, filter it, all that kind of stuff, build models, train your data science models, and evaluate it, and maybe go to a deployment. And what we've noticed is that in the first few parts, in the business understanding and data understanding, there's obviously a lot of communication between the data scientist and the customer. I mean, you have to understand the business, so you communicate with those who do. You ask the customer what they actually do, what they want to do, what the use case is for the data science project, all that kind of stuff. And at some point, you get the data, and you have to ask very similar questions. You have to ask how the data relates to the business, and what missing values, for example, mean, all that kind of stuff. But after that, we've made the experience that the data scientist often kind of goes into his own world. Once he's understood the data, he prepares it, he filters it, he generates features and trains models and optimizes performance. And all of that is typically done with few interaction with the customer, few involvement. Of course, you can show the customer some performance values or something like that, or some results, but I think that's not enough. So we can use the web apps as an early demonstrator during the project. And the first models at the beginning of the first modeling phase can be used for demonstrating if possible deployment. And that is helpful to show not only the possibilities, but also the limits of the project, because we've had the experience that some customers really undervalue data science and don't really know what possibilities there are. But we also obviously made the opposite experience at times, where the customer just thinks that AI is almighty and can do everything. So that kind of helps setting the expectations straight and shows them what they actually get out of the project. Another thing that's really helpful is creating acceptance for the end user, because they can be involved in the project team. Oftentimes, for the business understanding, data preparation, modeling, the end user isn't even involved at all. But here he can be involved once we have the web app. And it makes the project their project and gives them also a realistic view of what the project even can do. And that, again, helps with a better acceptance and higher chance of success. Another problem that I mentioned were the high costs, and they can often come as a surprise or as a shock. And we have the advantage that we have no extras necessary. Because we use RapidMiner, and its infrastructure and expertise. We don't depend on any external resources or third parties to make the web apps. And we can reuse previous results of the data preparation, and we reuse existing connections interfaces. We'll see in a second that it's all done within RapidMiner, within the RapidMiner repository. So we have everything done already when we started a project. And to show you how it's done, we'll follow one example use case from pretty much the beginning to a functioning web app. And the example use case that I thought about is a hotel chain, which gathers negative reviews about their hotels. They gather the data and label it, and they have several different hotels with several different departments. And the idea is to automatically forward all the negative reviews to the responsive department so they can just fix the problems or whatever. That isn't anything new, of course. It's a very simple use case. And our job is only to classify the department. So we already have the data for one specific hotel, and we know that it's negative, but we don't know yet which department it belongs to. So that's what we get some training data for, which you can see here. There's some ID, which is connected to some more metadata, for example, the date or the exact hotel where the review is, which the review is about. We have the text, and we have the corresponding department, which this text should be forwarded to. For example, the first row is just someone saying that the hotel is dirty. So that's something for the cleaning department. One thing to note is that we only have 4 different departments right now. And that is because the data science project started already before all the data was labeled. So we have 4 complete data sets for cleaning, maintenance, sales, marketing, and the staff. But there may be some more classes coming in the future within the project. For example, for the security or for the food or the IT. So that's something to keep in mind. And yeah, the project progresses, and right now we don't even have a web app, so it's just a normal data science project. We build the first models, and we get some performances and stuff. And the customer typically wants to know at some point how good the data science models, the machine learning models even work. So they ask something like, how accurate is the AI? And as our data scientists, this is our time to shine, and we start with the performance and maybe show confusion metrics or the resulting accuracy. But then we have to think about whether it's a balanced data set, because otherwise accuracy can be kind of misleading. Or we talk about precision or recall, or maybe can formulate a cost function or correlation. Or we don't do anything of that, because that's really at the core of the problem that I mentioned earlier. It's this disconnect between the data scientist and the customer. Of course, we can try to bring the customer into our world and speak about data science in a data scientist's way, but we can also let them see for themselves. And that's the idea behind this. So we speak with the customer, and he comes up with a solution, or we come up with a solution together, which is a very simple web app where we have some logo on top. Right now, we just use our logo because it's free advertisement. And we have a text field and a button. And when you click it, the text should be, the model that we trained, the best model right now, should be applied to the text and calculate some confidences. That's the idea. And then if we had something like that, the customer could check the model's performance himself and take a look at it. So how do we do that? And for that, I'll give over to my colleague Hatem, who is pretty much the brain behind the technical side of the WebAppBuilder, and he'll tell us a bit about how to get started.
So, hello everybody. As we already seen, we have some requirements for a simple web app. So what we've done in our computing, we've managed to develop an extension for RapidMiner Studio that a data scientist could use to build his own web apps with the tools he or she already have, and no further expertise are required. So as we are seeing right now, we have a simple tree repository project. We have all the data, the processes, our results, our models, etc. And for that, we add a single process called the web app, which will define our web apps, how it looks. So we create this process. In this process, we add a single operator. It's called the create web app operator. And in this operator, we add some sort of visual components, and we define the structure. And the resulting the result of this process is the structure of the app. So after executing this process, we get the web application. So for this application, I think when we have a small example, we will get a more better idea. So let's start with the famous one, the famous Hello World application. For that, we have, as we already seen, a create web app operator. It's just a sub-process operator. As if you're already familiar with RapidMiner Studio, you may have already done something with sub-processes. So in this create web app operator, we have a visual component. It's called a label. It's the simplest one available. In this, we add simple text, hello world. And after saving this process and accessing this web app, we see a simple application called hello world application with the hello world label. So as simple as that, we want to move to using this extension with our use case. So to do so, we'll need a more more experienced guy with the example use case. So I give to Chris.
Okay, so now we know the very basics of how the WebAppBuilder works. Let's take a look back at the web app that we want to build. And for now, we even simplify it a bit because the stuff at the bottom is a bit too hard for the beginning. We only want to do the very general design. So one thing to notice perhaps is that there are like two rows. Upper row is just the header and the rest is the body. And with that in mind, we dive into the create web app operator and we place two layouts. These are special components which subdivide the web app further. There are also sub-processes, so we can go into the header and place a label. The same label operator that we just saw for hello world can also be used with raw HTML. So in this case, we just enter HTML code for a picture. And for the body, we have a bit more. We have several columns, which are empty, and the middle column with the text field and a button. So these empty columns are just a design choice, as you can see in a second. And it's not the only way you can do it. You can also work with margins or paddings or some other CSS stuff. But I think it's the easiest way to make it look good and work in the way that we want to. So let's see how that works. We have, as I said, the label on the top and the text and button on the bottom. And that's already the resulting web app. As Hartmut already said, you just have to store it and enter it into the web browser, the correct address. You can also open the web app from the create web app operator. So as you can see, there's the top part and the bottom part. And in the bottom part, there's 3 different columns. And the middle column has 2 rows. So that's how the the very general layout of our web apps works with rows and columns and layouts. So now to get some more functionality, we have to go back to Hartem, who tells us a bit about how to make the graphs work.
Theoretically, we have our web app. It had a structure, as we already defined in this process, in the create web app process, but we need data. We need to visualize data. So where does this data come from? It comes from our repository, our processes, our results, models, what's so on. For this, I would call the left side the funny laptop with the web app as the front end, and the right side will be the back end. So we have two parties communicating with each other. So we need some sort of data. For that, we have two kinds of data. The first one would be the variables. If you are already familiar with RapidMiner Studio, you may have used macros or so on. These are the same. Variables are scalar values that will be used when in labels or some other thing. We'll see right now. And the bigger one is called the objects. They are the more complex data. Like we see tables of data, an example set, or whatever RapidMiner has for IO objects. So files, example sets, JSON, whatsoever. We now have some kind of data, and we have two parties, but they are not yet communicating. So for communication, we use some kinds of commands. They are called actions. They are transferred between the front end and the back end, the left and right sides, and they define how the app interact with the data. And we need to set some variable to a certain value. We need to do change the view on the front end or whatsoever. These are commands interchangeable between the back end and the front end, and they control the communications. So with that said, I think it's better done with an example. So we go back to our use case. So go back and Chris.
So let's take a look. This is the body part that we already made with the text and the button. And in the text, we can just connect it with the variable. We are uncreative and just call it text as well. And we also want to use some kind of action. So the button, again, is a subprocess. And if you look inside, you can use several actions. I'm not sure if it's visible depending on your on the size of your monitor, but the right part, there are actions, and they are executed consecutively. But for now, it doesn't matter because we only want to execute one process. And this is just a normal RapidMiner process. And in this case, we want to retrieve the variable called text. And we can get it either as a macro or as an example set. I think in this specific example, I used it as an example set, but both is possible. And then I do some kind of preparation. I apply the model and post-process it to look in the way I want it to. And then I publish it as a web app object. So to summarize, we have the text variable, and with an action, we execute a process which gets the variable and publishes an object. So these are the three parts that Hartem just spoke about. So start with the text and end with the confidence object. That's what I call it. Again, you can use any kind of name. I just use the simplest one that came to my mind. So how do we use it? We, again, take a look at our body, and we want to use a height chart. Height chart is a JavaScript library for displaying all kinds of charts. I think they're kind of pretty, and they're especially performant. And we have it built into the WebAppBuilder extension. And It's again a subprocess which can use several kinds of plots. In this case, we just want to use a bar plot, which uses the confidences object that we just published with the button click. And this looks like this. We are pretty much done already, except for one thing, which is that the web app doesn't work yet if you start it the first time, because we don't know what the object is, we don't know what the variable is. So we need to initialize it. In the create web app operator, we have a process for the initialization. And in this, we can just publish some kind of starting object. You could also just publish real confidences at the start, but I just publish the values 0 as a confidence for every class. We also have to define the variables. In this case, we just start with an empty text. And this results in the web app being shown like this at the very start. There's no text, just a placeholder that we entered into the text field. And at the bottom, there are the confidences shown in a bar chart with value 0, so you don't see anything. And yeah, that's the first finished web app. What we kind of found very helpful is the tree view from RapidMiner, where you can see the whole process irregardless of how many layers there are within just one tab. So you see the process with the create web app operator, which is at the very top of the project. Then you have the header with the logo. You have the body part with 3 columns, and the middle column has a text, button, and the process execution and the high chart. And if you enter some text, click on the button, it looks like this. So this is the first very simple web app already done. And in our example use case, the customer uses this web app a bit. He tests some kind of stuff and gets a bit of a feeling for how good the model works. And after a while, when the project progresses, the decision for the final deployment has been made, which is that all reviews with a high model confidence are supposed to be automatically forwarded. And whenever the model's confidence is rather low, they should be manually checked again. And then you can retrain it and all that kind of stuff. But for now, there's the decision left what the threshold should be for whether to automatically forward or to manually check again. And we could do it in a data science way and see how high the threshold should have to be to ensure some kind of accuracy or some kind of recall. But the customer wants to set the threshold manually. So what we decide on is that we want to have a web app with a confidence ranking for every class. So the customer can look how high the highest confidences are and go down this list and kind of get a feeling of which threshold he thinks is okay. So we don't want to build a separate web app, we just want to add it to the existing web app. So let's go back to the body part. It's still the same web app, only a few things have changed. For example, there are some component settings for the high charts. We can use arbitrary JSON code for the high charts settings, which can be quite complex if you want to delve into it, but you don't have to. Again, just part of the high charts library. And we want to put all of these operators inside a so-called multiview. This multiview allows us to not have it static, but switch between different views. And for that, we have several different layouts. In this case, we only need 2. We have one for the simulator that we already built, and one new layout for the ranking. So what we do is we just put all the operators we already have built for the first view, for the first finished web app, into the first layout. Now we only need some way to switch between the 2 layouts. And the most convenient way is just a sidebar. And in the sidebar, you can select the multi-view that you want to switch views on, and give some names and optionally some icons that should be shown with it. And you just have to say how the separate views are named. In this case, they are named main multiview simulator and main multiview ranking. And this results in this. So it's still the same web app, but with a sidebar where you can see the simulator with an icon that I chose and the ranking with another icon. If you click on the ranking, you get to see an empty layout, which isn't too exciting. So let's go into it. We have these two layouts, and in the ranking, we want to add a data table. A data table is just a way to show an example set as a table. So it links directly to an object, which should consist of a RapidMiner example set. So we have to publish this example set somehow. So we do it in the initialization, and don't have to look at that RapidMiner process too closely if you don't want to. It's just getting the test data, applying the model, and sorting by the confidence. So the highest confidence is on top. The rest is just visual stuff like renaming. And this results in this. We have all the texts and the confidences with the highest confidence on the top. And we for now only have one of the 4 categories. In this case, we have the staff category, as you can tell by the text. It's about the reception and staff and some people at the reception again, that kind of stuff. So we don't have only one category, we have 4 categories. One thing we could do is building one data table for every category. But I mean, that would work, but we really don't want to do that. First of all, as I already mentioned in the beginning, there will be more classes later on, more different total departments like the security or the food or the IT. So if these classes later on if we later get data for the other classes, we would have to add tables again. And we might want to add some functionality, or we might want to change something about all tables. So we really don't want to use this approach because we are lazy. And you already saw how I prepared one of the objects. I mean, I applied the model and sorted and all that kind of stuff. If I want to prepare 4 objects in RapidMiner, I don't copy the process and change it 3 times. I would use the loop. So why don't we just use a loop for the web app? And we can do just that. We can loop over the categories. In this case, I use loop groups from our Jackhammer extension, but any kind of loop works. You can also use loop examples or the very standard loop from RapidMiner. You might have to add some kind of operator for the macros for it to work. So I just chose it for the convenience. And within the loop, we have the data table that we already built. We just make a small change and retrieve the corresponding object depending on the category that we currently loop about. So 4 times data table with 4 different objects. And then we get this. It's exactly what we asked for. So be careful what you wish for, because it's, in my opinion, quite cluttered and you don't really see which category is. But it works. You see in the first category, it's about the cleaning. And you see the most confident cleaning test predictions. Second category is about maintenance, something about stuff not working, and so on. There's one way to make it in a very simple way, much more pretty and useful. So we can just put the loop inside a so-called accordion layout, which will allow us to switch between these 4 tables easily. We just need to put the data table into a layout for that, because the accordion layout takes several different layouts. and allows switching between them. And that's the result. We see the cleaning on the top and the other categories which are currently not expanded. And you can just expand the maintenance, and then it looks like this. And then you can look at the different departments and look at the confidences and set a threshold. So let's say that the customer now wants to add some functionality because he thinks that he really wants to have some option to see what the model would have done if the text was slightly different. So he wants to be able to click on a row, in this case, just the first row with the text "bed sheets were dirty." And he wants to click on some kind of button. And he wants then this text to be entered into the simulator. And he wants to see the confidences. This is quite convenient because he can understand the model better. He can test different variations. For example, what if it wasn't the word dirty that was used, but not clean? And you can also look at the confidence for other classes. For example, when the confidence is 0.7, you might be interested in what the confidence, the rest of the confidence look like. So let's do just that. We take a look back at what we just made. And at the top layer, we have the accordion, then the loop, then the layout, and the data table. We only need to look at the data table. The rest just stays the same. And we add some functionality there. In this case, a button. This button is supposed to bring us to the other view and do some kind of calculations. So we give it some actions. Now we have more than one action. The first one is just changing the view because we want to go over. And here we have several options. We could have done the order in a different way. But as I already said, the actions are executed consecutively. So if you change the way and if the process that we are about to go into takes a bit longer, then the view change would also take place a bit later, which might feel a bit unresponsive. So that's just the way that I chose. The second is that I set the current category, which we have as a RapidMiner macro, as a variable, because we need to have some defining factor that defines whether we are in the data table for the staff or the data table for the cleaning or data table for maintenance, and so on. And last, we have a process which extracts the relevant text of the relevant table and executes the same process that we already executed in the first part of the web app, where we apply the model and publish it. So let's take a look. We have a button. We can click on some text, click on the button, and get to the simulator and have it already applied. And this concludes the use case. And I think what we've seen is that it's rather simple and fast to build, especially if you're a RapidMiner user, because it reuses experience that you might have had if you are very familiar with RapidMiner. And it has the same flexibility and reusability as RapidMiner processes, literally, because it's RapidMiner processes. This is not only limited to loops, which I wanted to show in the last section, but you can also literally completely reuse templates that you already made. So in this picture, you can see you can have a new body part that you make for some web app, but you can reuse a header from a previous web app because it's just the inclusion of a new process. Include process, by the way, is very similar to execute process, but it's guaranteed to work within the web app context. Like it works with objects and variables and the actions and the users. So essentially, it's just executing a sub-process. So I have some more examples of web apps that we built. This, for example, is one that we made for the RapidMiner Wisdom in 2020. And it is about cardboard boxes and predicting how wet they are, because that's quite a problem when creating cardboard. And it's not a real web app, similar to the use case I just showed. It's made by us to showcase some features. And you can see it has a sidebar similar to ours. It has multiple line plots. It has a tab view, which is similar to side views and multiviews. In this case, we can switch between parameters for the live monitor and for the control panel. And we have sliders. Another example, which was an actual project, so I censored it a bit, where we predicted sewage. So you have a way to select a date, and you can checkbox. You can use a checkbox to activate a timer, which then simulates the time flowing forward in fast motion. So you can see how the web app would show the predictions over the course of several days. And you have error bars that are used for the confidences. And yeah. One more web app that we use productively, which is pretty much the inspiration for our simple use case that I showed, where you have some texts from emails, I think, and you have several things that we want to predict. You predict some kind of category, who's responsible for it, how important it is, the problem, and what the implications of the problem are, whether they can continue working and all that kind of stuff. So it's also a simulator. And there we have text fields and we have bar charts again. And we use error bars to show the confidences that, if I remember correctly, but I didn't do this project, my colleague did it, the error bars show how high the confidences have to be for the prediction to choose, for the model to choose this class. It's similar to the threshold that we spoke about in our project. Another real web app is this. It's a BI dashboard, pretty much, which has icons for tooltips, drop-down menus, data table, and many more things. Thank you for your time. This concludes the presentation. As I already briefly mentioned, we do data science consulting, but we also have support and development. So if you need some kind of support for your project, if you want to have help with starting your first web app, we can do just that. If you have any more questions, just write us. Hope to see you again, and have a nice day.